just hit send. I want to see, make sure everybody's got this. Yay. Very nice. So you guys are good in the hood. I love it. You can put the 1/2 on the outside. You can expand it to ln5 minus ln4 if you really want to. All sorts of ways to do this. So what we're going to do is switch gears a little bit. You've been working with exponential equations where you get it into an exponent equals blah, and then you take a log of both sides. Or the other way that we were considering working on these is, hey, what if it's already in logarithmic form? If it's in logarithmic form, well, you can do the same thing. You don't have to turn it into anything else in most situations. So I have steps, and I think, yeah. Okay, so I'll show you these steps, and then we're going to go through one, and then we'll revisit them so you can see the context. Because oftentimes steps are not helpful unless you know what it looks like in the problem. So you've got a logarithmic equation. Sometimes you might have a log on both sides. Sometimes you might just have a log on one side. So the first thing you do, if it's not already isolated, isolate that log. And then, if you only have one logarithm, just rewrite that expression in exponential form. And from that, you can solve it. And those were ones where you guys actually did those. So that's sort of a retread of what we did. And we may have even talked about this, I think we did, where you got to check your solutions. Because you know that anything that causes the argument, which if you have like log x, x would be the argument. Anything that causes that to be 0 or a negative number has to be discarded. It's not within the domain of a logarithm. So remember, a logarithm doesn't pass the vertical line x equals 0. So you have to discard those and call them extraneous. Another variation on the theme, which is hiding here, is, well, what happens if I logged on both sides of the equation? That's okay. Maybe you can't put them all on one side of the equation. You get some weirdo thing. Or it's just way too much work. So put one on one side, put one on the other side. If they have the same bases, then you can set the arguments equal to each other and solve that way. The only catch for this, again, is when you get those answers, you have to check and make sure it's not going to make an argument negative or 0. So those are the stipulations. And we'll come back to that in just a second. I want to show you in context what this looks like. So this is scenario number 1. I've got log, and then you got stuff equals 3. How can I rewrite this in exponential form? What to the what equals what? How would you write that in exponential form? Nikki, how would you do that? Some of you, I think, are just typing it in. Go ahead. Okay, so what I think you said is 2 to the third equals x squared minus 3x plus 10. Is that what you said? Oh, good. Okay, because you were really, really tiny, and I wasn't sure if maybe it's my speakers. I don't know. But notice I've got a base. This is the stuff that you did for homework. The base to that exponent equals the quadratic. And then I can just move this. You know that this is 8 equals x squared minus 3x plus 10. Incidentally, these notes are the same notes that were on Blackboard. We had done part of them, and then we just didn't finish them. If I subtract 8 from both sides, you're going to get x squared minus 3x plus 2. And then I factor. You guys are factor kings and factor queens. So how does this factor? I mean, I know you got an x and an x. How am I going to get the minus 3? Very nice. So it's going to be minus 1 minus 2. Set each of those guys equal to 0. So this is just old fun math. I'm writing really slowly. My arm was freaking out this morning. I didn't sleep hardly at all because I'm itching so badly. So I have ice on it, and it's really hard to move the muscles when you have ice on your arm. So if this looks particularly crazy, that's the story behind that. I don't think I slept more than an hour last night. If anybody has eczema, you'll understand what I'm talking about. It's very painful. Okay. So, but I'm not done. When I get to here, I got to check each of those. And really, all you have to do is plug it in the argument of the log. So I'll write this, log base 2 of 1 minus 3 plus 10. So that's just going to give me log base 2 of negative 2 plus 10, or log base 2 of 8. You really don't have to do all of this stuff. You're just checking to make sure that this stuff, when you plug it in, is not negative. As long as it's not negative and you didn't do something weird, then that number is going to work. So one of my answers really is x equals 1. So let's try it for the other one. So we're trying x equals 2. So I'm going to have log base 2 of 2 squared minus 3 times 2 plus 10. I'm not even writing the rest of this. This is going to be 4 minus 3 plus 10. I'm so sorry, 4 minus 6. Grr. Grr, grr. Get to that. I wanted to white it out, not blue it out. Okay. Anyway, so you plug that guy in. This is going to be minus 6, sorry for the delay, plus 10. Are we good? Is that going to give me a positive or a negative? That's really what I'm checking for. Is that an okay answer? Jane, what do you think about that? Is this okay? Does 2 work? You there, Jane? Oh, sweet. Okay, good. It works. Now, if you figured the rest of it out, it would also, I mean, you could actually go further than that. But as long as this is not negative, then we're fine. So you're looking at these guys, and you're deciding, hey, is that positive? Is it negative? What is going on? So this is a positive value. This is a positive value. So both of these are going to work, and we're done. So let me return to the previous screen. This was the one in the beginning. I'm trying to get a hand. Okay. This was, hey, isolate the log. We didn't even have to do that. It was already isolated. We rewrote it in exponential form. We solved it, and we checked. So that's one type of logarithmic equation that you can get. The other type is hiding under a purple square. Yes, it's a rectangle. Okay. So notice this time we've got logs that are, in fact, this is actually going to be the first type of problem too, now that I think about it. So I can't just do 4 to the first for this one. Somehow I've got to get one logarithm on one side, and if you have a log on the other side, that's fine too, but I need logarithm equals number. How can I put this together? I've got log base 4 of blah plus log base 4 of blah. If I'm adding exponents, what do you do? Very nice. Exactly. You're going to multiply the arguments. And I keep talking about arguments. the argument is the thing inside the log. So we're going to say, okay, fine, that's log base 4 of 2 minus x plus 3 equals 1. If I rewrite that in exponential form, I've got 4 to the first power. So 4 to the first equals, actually, I'm just going to go ahead and FOIL this. FOIL it like you mean it. Okay. So this is going to be 2x plus 6 minus x squared minus 3x. I just want to triple check and make sure I didn't do anything silly. So 2 times x is 2x, 2 times blah is 6, negative x and x is negative x squared, done. Okay, at this point I've got a quadratic. That's extremely nice. If I set this whole thing equal to 0 and readjust it, actually I'm going to move everything to the other side. I don't want to deal with a negative x squared. That is annoying. So let me wipe this out yet again. I don't know why it continues to go. Okay. Gosh, I'm writing so slowly today. How annoying is that? Okay. So if I move the 6 over, I'll get negative 2. Oh, let's see. And then I'll have an x, and then I'll have an x squared. Let's make sure I didn't do that weirdly. Okay. So negative 3 and 2 is positive 1. This comes over as a positive. If I do 6 from 4, I get negative 2. Okay, so then I get to factor. So Katie, how does this factor? Oh, I have 2 Katies. Katie squared. How about Katie Willis? How does this factor?
X minus 1 and x plus 1. Oh, no, sorry. X minus 1 and x minus 2 and x plus 1. The opposite.
You're very close. Yeah.
X minus 1 and x plus 2, sorry.
You are pulling a Reuben right here. Okay, so I get x is equal to 1. I get x is equal to negative 2. So I want you to check these. Sometimes they both work. Sometimes only one of them works. Sometimes neither of them works. So what I'd like you to do is text in your answer, but then wait. So I want you to check these. And you're checking them, notice, in the original equation. You're checking them in this exactly as it is. And all you care about is, okay, is that going to give me a negative argument? So I just need the final answer in the text box, but then wait. So that we're sending them all at the same time. And I'll wait for everybody's text box to light up. Remember, we're throwing these numbers, a 1 in here in the original thing, and saying, hey, is that going to make one of those arguments negative? If not, 1 will work. Try the negative 2. Is that going to make an argument negative? Or 0? If that happens, we're throwing that out too. So I'm waiting for, I guess, Katie squared, the 2 Katies, Minsung, Peter, and Ryan. And it's not to rush you, I just wanted to make sure that you understood what we were doing. So I just want final answers. so Jeff and Katie Willett, if you guys would just weigh in your text box and then just wait. Okay, shoot it out. Gorgeous. Absolutely, they both work. And this is something I really want to point out. A lot of people think, oh no, I got a negative. I have to throw that out. Not necessarily. You can see if I put a negative in here, that's going to cause a positive. If I put a negative in here, that's going to cause a 1. So don't think that if you get a negative number, then automatically that's bad. It all depends on what happens with the equation that you're on. Okay, so give me a check mark. Get where we are. We're ready to roll. You're good in the hood. Just a check mark. If you put an X mark, that's okay too. If you're still writing it, that's fine. So Amanda and Andy and Anish and Austin, just want to make sure you guys are okay. Case, are you doing okay? We just need a mark of the check variety. Are you there, Case? There we go. Awesome. Okay. So same story with this one. Let me have you guys do this one independently. Or maybe not. You're going to have time for breakout rooms. Let's do this together. Okay, so the conundrum with this is I don't just have a logarithm and a number. I have the 5 in the way. So I'm going to, like any other equation, ln x, we're just going to treat this whole thing as the variable. Move the 5, divide by 2, and then rewrite it. So let's do it. If I move the 5, I get 2 ln x equals negative 1. If I divide by 2, I get ln x equals negative 1/2. Remember that this just means log base e. So if it makes you happy, it used to make me happy to actually write log base e equals negative 1/2 because I'm visual. So I like to see, hey, here's my base being raised to a power. So I get e to the negative 1/2 equals x, or you could say 1 over the square root of e. I don't care anymore if you have square roots in the bottom. It's actually no more simple than rationalizing it. You could even leave it with e to the negative 1/2. So at this point, we start to drop those things like, oh, you can't have your answer like that. Please just stop. So we spend a lot of time. And the reason isn't because we want to frustrate you. It's because when you see things on multiple choice questions as you go along in math, you have to know that those are equivalent. Because they may not have e to the negative 1/2, or they may have rationalized this. So you have to recognize that all of those are the same. Okay, and then I'm going to check this also. So if I say 5 plus 2 ln e to the negative 1/2 equals 4, this is a positive value. I actually really like this problem. I like to actually work it out because it's cool. You can take the exponent. You don't have to do this, but you can bring this down here, move the 5, and then you will get the answer that we're talking about. But really, all I care is that this is positive. As long as that's positive, we are good in the hood. Okay. Let's see what's hiding under the lavender. All right. Okay, so we're moving up the food chain here. I've got ln blah to ln blah. Heaven. So you've already told me that if I have two things added, then I can put this, because remember, I can't have logs all spread out like this, but I can have logs on both sides. So this is the second type of problem that is on that page. So I'm going to put these guys together using multiplication. So ln x minus 2, 2x minus 3 is 2 ln x. And I'll go ahead and work this stuff out. This is going to be 2x squared minus 7x plus 6, I think. Just make sure I didn't do anything. C. So x times 2x is 2x squared minus 3 minus 4 is negative 7. Oh yeah, that's right. Okay, and I also want to fix this over here. I don't want the 2 in front. What can I do with this 2 so that I just have a natural log on both sides? Where could I move this 2? Very nice. So I'm going to shove it back up into exponential form. You guys are so awesome. It's so fabulous. Okay, so I'm going to say this is ln x squared. If you want to put parentheses, you can. Now I've got natural logs on both sides. Log base e of blah, log base e of blah. This is where you can set the arguments equal to each other. Just drop the natural logs. Please don't divide by ln. That's not what we're doing. We're saying if these bases, if they're both e or 5 or whatever, you can set 2x squared minus 7x plus 6 equal to x squared. So just make a note to yourself, don't divide by ln. Probably shouldn't even put that in your head. It would be as though I had like sine pi over 6 equals 1/2, and if you divided by sine, you got pi over 6 equals 1/2 over sine. Right? I mean, that's crazy. You would never do that. So just like you would never divide both sides by sine for this, you wouldn't do that for this one either. Okay, then I get to simplify it. So x squared minus 7x plus 6 equals 0. That's going to result in x minus 6, x minus 1. I'm going to get x is equal to 6 and 1. So again, I want you to check those and tell me if they both work, if neither works, if one or the other one works, and just text it and then wait. So Tyler, I think I'm waiting for you and Lauren. Yeah, I think that's it, just you and Lauren. Okay, shoot out your answers. Nice. Very nice. So you guys are saying only 6 works. Because if I plug 1 in, I'm going to get a negative argument, which is not cool. Jeff, do you want to shoot out your answer? Awesome. Awesome, awesome. Okay, so we're going to go into breakout rooms. And let me just, whoa. Hold on. Just trying to get this ready, so let's see what's going on. No eating during class. Oh my gosh. Please eat. It will sustain you. All right. Okay, you guys. So you guys are going to be in groups of 2. And in so doing, you can write your name. And I'm just taking a screenshot of this so that stuff doesn't move. Okay. All right, so groups of 2, put your name down and make sure that you check stuff. And then I would definitely check the other person's work as well. So do both of them and then decide who you would like to have write down. But you both have a role. Do this. Breakout rooms. 2. Okay, guys, so I saw a lot of really great work. And I just grabbed one of them. So whether you were writing or typing or whatever, you got down to here and -3 didn't work because when you plug it back in, the -3 messes up this right here. Actually, changes both of them. They're bad. Bad -3. But 4 is okay. So very nice. And then this one, you get -1/2 and 3. The -1/2 isn't not working because it's negative. It's just when you plug that into here, you're going to get a negative. Actually, you get a 0 right there. So that's not cool. Okay, so give me a little emotion. I'm good to go. I know what's going on. I am happy that we're done with the class. Isn't that crazy? We're actually finishing in the allotted time. That is extremely hard to do. But that's why I broke this particular concept up, because it's worth understanding fully logs and exponents. That's huge. It'll follow you everywhere, like a shadow. Okay, cool. Well, then we have an exit ticket, and once you have clicked on that, you are welcome to take off. And that's a live link, so you can actually just click on that.